Greetings, fellow mathematicians. We're going to take a look at two of the most useful tests for determining if an infinite series converges or diverges with what are known as the ratio and root tests. We're going to understand what the conclusions are of these tests, and then at the end we'll take a look at some tips and tricks for applying them. Now first, a new concept is introduced called absolute convergence, and it's really simple. The definition basically just refers to taking the absolute value of the term of your infinite series. So the word absolute here refers to absolute value. All right, most importantly, there's a theorem that relates absolute convergence to convergence, which basically says if your infinite series is absolutely convergent, then it is also convergent. In other words, absolute convergence implies regular convergence. With that out of the way, let's get to understanding the ratio and root tests. Now, they both apply to a standard infinite series. The terms could be all positive, some could be alternating positive and negative, it could be an irregular pattern, doesn't matter. But we take our term a sub n and calculate two related limits. The conclusions are going to be the same for the ratio and root test, but what we calculate will be different. For the ratio test, we're going to take a look at the limit defined as the ratio in absolute value of a sub n plus 1 divided by a sub n. And that's where the name, the ratio test, comes from, because we're taking a ratio of terms. We're going to take a limit as n goes to infinity, and that's how we calculate the limit here, L, for the ratio test. Now there's a similar limit that we're going to calculate for the root test, but instead of a ratio, we're going to take a look at an nth root. So we have a sub n, we're going to take the absolute value of that. That's because when we deal with certain roots, we don't want to have anything become undefined as a real number. Absolute value takes care of that and gets rid of any negatives. And then we're going to take the nth root of the absolute value of a sub n. And again, after that, take a limit as n goes to infinity. So the difference between ratio and root tests is what limit you're calculating, but both come from your term a sub n. Now there's some different tips and tricks that apply to simplifying these limits. We're going to get to that in a little bit, but first, the conclusions between these two tests are exactly the same. There's three conclusions. This limit for either part, if that limit L is less than 1, then your infinite series is absolutely convergent, which from the theorem over here would imply that the infinite series is convergent. All right, the second conclusion, which is nice, if your limit is greater than 1 or infinity, your infinite series is divergent. So this test or tests not only tell you if it converges, but also if it possibly diverges. There is a third possibility if the limit comes out to be precisely 1. And if that happens, the ratio and or root tests would be inconclusive, so you would just apply another test. So this is really simple in some sense. You have an infinite series, calculate either one of these depending on which test you're applying, and then you have three simple conclusions here to determine if it converges or diverges from. Now the tricky part is determining which one you would want to use and then how you would simplify the limit here. And we're going to get to those tips and tricks right now. There's three useful tips that you'll want to use when you apply the ratio test. The first one might seem really obvious, but it's to when you calculate the term a sub n plus 1, replace all n's everywhere with n plus 1. Again, that might seem really simple, but definitely do that. All n's replace with n plus 1. The next tip is going to be incredibly useful whenever you counter factorials. Due to the incrementing here, replacing n with n plus 1, you're typically going to get n plus 1 factorials. And there is an incredibly useful property here for factorials, which allows you to simplify this. We can write n plus 1 factorial as n plus 1 times n factorial. And in most problems, when you're applying the ratio test, the n factorial term here at the end will eventually cancel out. So keep that in mind if you're going to apply the ratio test with factorials. The last tip for the ratio test is a basic exponent rule, which is sometimes overlooked or not really mentioned in a Calc 2 course. And it deals with when you have nth powers. Now, let's say we have 2 to the n plus 1. The term here, a sub n, might have contained 2 to the n. Replace n with n plus 1 to increment, and you might get something like this. Now, a lot of students I've encountered really don't know what to do with this, but we're going to just reverse a basic exponent rule. And I can split this up due to the addition in the exponent. I can rewrite this as 2 to the n times 2 to the 1. And again, this is a basic exponent rule. You're probably most used to applying this going from the right side to the left. In other words, multiply same bases, you can add the exponents. Here, we're just reversing that. So likely when you apply the ratio test, these 3 tips will probably get applied to most problems. Now, the ratio test is by far much more useful than the root test, but there are some infinite series where the root test will be really easy to apply. And the one thing you want to look for, the one main tip for when you want to apply the root test, is if your term of the infinite series has an expression raised to an nth power. Now, I don't care how complicated the inside is, but if there's an nth power on the outside, the nth root will simplify that. So if this is our term for a sub n, let's calculate the nth root of that. And if we go ahead and plug in our formula here for this general example, we're going to have an nth root of the absolute value of that function. I'm just going to bring the power outside of the absolute value. And what we're going to notice here is that an nth power and an nth root should cancel, but be careful to keep the absolute value there. And what we get is the absolute value of basically the part that we were taking the nth power of. In other words, it simplifies to the part inside those parentheses. Now, this doesn't happen for a lot of examples, but there's a few that you're likely going to encounter where the root test will make quick work to determine if the infinite series converges or diverges. So again, just be on the lookout. If you have something raised to an nth power, one example of what that might look like, just to give a concrete example of a general term rather than a formula here. Let's say a sub n looks like 3n plus 1 divided by 4n plus 3, and all of that is raised to the nth power. All right, and again here, the key thing is that nth power, take the nth root of that, and that will basically cancel out. Hope you enjoyed this short video, getting straight to the point of how to apply the ratio and root tests, and then some tips and tricks for applying those 2 tests. If you enjoyed the content, support the channel, hit the subscribe button.